I got it. I'm recording now. For those of you guys again having Wi-Fi issues, totally fine. Now it's being recorded. You know. Um, hold on 1 second. So now I'm not being dumb and not recording. So we have 12 days left. No, 12 days left. But when we're talking Zoom classes, you only have 6 days. You have 4 next week and 2 the week after that. So 12 days, including weekends, 6 days in Zoom. Remember, we have tutoring. Review for our final will be next Thursday and Friday. So please be here for Thursday and Friday. And then the last 2 days of actual class is the 8th and the 9th. And both of those days, we will be taking our final. The reason why it's 2 days is because it's going to take us 2 days to do it. It's 18 questions. And they refuse to allow us to like make it, smaller. So we're kind of stuck with it. The last day is technically March 10th, but that's a Wednesday. So unless you guys come during tutoring time, you're not good. Like I see you on Tuesday. Now, the last day to turn in any assignment whatsoever is March 9th. That's it. Once March 9th is done, we're done. Right at the end of this class, so at 11:30 on the 9th, that's it. I don't care if you turn it in the next hour or you try and give me some sob story about your Wi-Fi. Don't wait till the last second to turn things in. All right. Make sure that you guys are doing it correctly. If you guys normally have Wi-Fi issues, make sure that you guys are in a spot where you guys are not going to have Wi-Fi issues. Because once the 9th is done, that's it. I want to turn in grades on that day. End of story. I want, because it's a pain in the butt having to turn in the last set of grades for students. So, because I need to send them copies of everything, and it's a huge process. So I'm done.
So don't even wait till the last moment, because actually that's during that period time we're working on your final.
Yeah. So I'm not going to even look at your stuff. So again, we want to get everything absolutely done. You should have everything done by Monday. Yeah. So try and get everything done by the 8th versus the 9th.
That whole weekend.
We can have that. Yeah, you have the whole weekend, and we're not giving you guys crazy assignments next week. So you guys should be able to do absolutely everything in class. So zero excuse to not doing your stuff in class. You don't even have to be in Zoom land to do your assignments, for next week, except for Thursday and Friday, because those are notes that we're doing it on top of it. For today, we are going to finish up your notebook. So once we're done with our notebook, page 8, you guys can turn it in. And then you guys do have a substitution homework assignment. I think it's like 6 questions. Some of you guys are like amazing and have already done it. Actually, you did it before, like you did it a couple of days ago, which is crazy. But if you guys could follow me to, not that. There we go. Go to classwork and then go to week 8 notebook. Couple of things before we get started. Can you type? There you go. Doc 3. If you guys didn't know by chance, you see this corner grid right here. If you click on it, you actually get to see all of your pages, and you can scroll until you want to get to a certain page. Just to let you guys know, I forgot that we were supposed to do a bell work yesterday. So I'm giving it as extra credit if you guys want. Remember this page, that was extra credit. And the your turn for today, I'm even doing that as extra credit because first period didn't get to go this far. You guys will, at least for the very first question. But honestly, once we're done with this page, you technically are done. All right. So this last page right here will be the last page for your notebook. if you guys want the 30 extra credit points, and I don't give out that much extra credit, you know, yeah, that is a lot. So if you guys want those 30 extra credit points, you know, by all means do that. Some of you guys have a lot of you guys in this class have A's. You might not need to do this, but some of you guys are overachievers, and even though you don't need it and you have like a 99%, you're still going to end up doing the 3, you know, pages because you guys are, you know, overachievers. God, overachievers. So probably, yeah, I kind of expect that. So if you guys could follow me to Bellwork Friday 2/26, it's page 6. I'm going to give you guys the length of a song to work on this assignment. Now, for those of you guys in Zoom land or YouTube land, I am going to solve this one as the song is going on. Yeah, I remembered. So you probably won't hear me explaining this one, but you'll at least see the end results once YouTube is done or once I unpause this. So I'm going to do this. No, not that. Resume recording. Awesome. All right. So for the first one, we see all the work that I did here. We subtracted 2, we divided by 6, and then that gave me a positive 3 because a negative divided by a negative gives me a positive. For the next one down here, this specifically is telling us that we're solving for y. And I see that I have 2 variables. I have an x and a y. So I want to make sure that this y is by itself. But there's no way to get rid of this x. So I know when I'm writing my answer, it's not going to be like this and it's going to be a single number. It's going to end up being an equation. And since we have an x and a y, we can kind of assume that it's going to look something similar to like the slope-intercept form, because this is technically standard form. And I don't know if you guys remember way back when we covered standard form. But if not, no big deal. Just solve for y. Do the exact same steps as you did up here, only now you have an x, which makes actually life easier. So I see a positive 3. The opposite of a positive 3 is a negative 3. So we're going to subtract negative 3x from both sides. And my 3x's go away. I'm left with negative 4y. Now, here is the part that a lot of people mess up on. I see this negative 3x and I see this 8. And a lot of you guys might think, okay, 5x. Is this correct? And if it's not, what was the mistake I made? Does anyone know? What was my mistake?
The 8 is a whole number and the negative 3 has a variable.
Yeah, so since the 3x, the negative 3x has a variable, we can't add or subtract it. We can't combine it at all with this 8. So it's going to just be side by side. We covered this again a while back. We're just bringing it back. This actually is going to help us, you know, with our notes today, moving forward. So we're going to just put it side by side. Are we done? No, because I still need to get this y by itself. And there's this negative 4 just still hanging around and it being annoying. So we need to get rid of this negative 4. It's like that annoying like little brother or sister that won't leave you alone. So negative 4, we're going to divide this. Why are we dividing instead of adding? Because these two are next to each other, and that means that they're being multiplied together. So what's the opposite of multiplying? Dividing. So we're going to divide by each of our numbers. All right. So my negative 4s go away. I'm left with y equals A negative and a negative. This is where that negative type divided by a negative turns into a positive. So these negatives go away. But look at the 3 and the 4. Can I simplify that? No. And please don't put that as a decimal. We're just going to leave it as a fraction. We're not going to touch it because I can't do anything with that. And then the x is just going to go to the side. However, on this side, a positive and a negative, that gives me a negative. And 4 does go into 8. I can simplify this. So 4 goes into 8 2 times. So then my answer is all of that. It's that whole equation. So 3 over 4, that's a horrible 4.
Not too bad.
Why did you put that? Why are you going that backwards?
That's
Okay,
weird.
Yeah. Oh, and it erased this part.
Uh-oh.
What? Stupid class kid.
Nice 3.
There we go. Much better.
Perfect 4.
X and then minus and 2. Again, guys, as you guys are doing your homeworks, if we don't see the work, then I'm not going to give you guys credit. So make sure that you guys are showing the work. Like yesterday, you should have graphed everything. For today's assignment, you should be showing all of your work like this. If you don't want to draw it like I did, you guys could always come here and then just write it down and then just move the pieces over and draw and type it up like that. So you could do it like this as well. It's up to you guys, but see, it still works. Okay. All right, for those of you guys having internet issues and need to see all of this, take a screenshot. And then I shall, now, let me know, is there something in either one of these questions that you guys do not understand? Because both of these questions will be on your final. So if there's anything you guys do not understand about either one of these, if it's a step, let us know. Which one?
The second one.
What about it?
For Y. For Y.
So you don't understand all of it or just a piece of it?
Just how do we get Y?
Okay, so I'm getting a couple of questions on this one. So let me actually start this one all over again. Because I got quite a few people going, can you do that one all over again? Because I didn't realize that this is going to be on the test. So I wasn't really paying attention that entire time that you were doing that.
Once you mention it's on your final, it's like,
I know. All the stuff on the bell work is on your final, guys.
Mm-hmm.
All details. Yes. All right. So again, we're trying to get the Y all by itself. So we're going to do the upside down T just like we did before in this question. All right. It's solved the same way. It's just that you're not going to be able to combine anything. So we're subtracting 3x. Why are we subtracting? Because this is a positive 3x and we're moving it over to the other side. So I'm going to subtract 3x from both sides. That's the opposite of a positive 3x. So then these guys go away. I'm left with negative 4y equals. And again, I can't combine both of these two because this 8 doesn't have an x. So I'm going to do negative 3x plus 8. All right. So far, thumbs up. We're all good with that first step.
Doc,
Number 1. Yeah.
but why can't you like divide by -4 right away?
Technically, I could.
Mm-hmm. But
Um,
then you'd be working with fractions right away and subtracting and adding fractions. And if you're a fan of fractions, I guess.
yeah, I always multiply or divide at the very end, especially divide, because it could mean that you're going to end up with a fraction. Now, if this 3 was like a 4, then it wouldn't matter because then I don't have any fractions. But since this is a 3 and I know that 4 doesn't go into 3, I would not divide first.
Or think about PEMDAS or order of operations. We're technically going backwards. We're doing the opposite of evaluating.
Yeah,
So-
and it's the same thing here. Like you wouldn't have divided everything by -6 right away. You subtract it by 2 and then divide everything by -6. You know, the process that we've always shown you guys makes your equations a lot easier to understand versus you guys ending up messing up somewhere. Here, the difference between this 3x and dividing by -4 is that this is being moved over to the other side, and I'm just this is technically like adding a 3x. So I'm gonna add a 3x to this other side, or subtract a 3x to this other side so I can combine them. This one, however, I need to break these two guys apart. They're dating, and I need to make sure that they break up. You know, the Y is a bad boy, and she, you know, the 4 shouldn't be with that bad boy. So I'll be honest, when I used to teach algebra 1 and we did like radicals, and you can't separate the x plus 1 or whatever, I would have a like speech about like marriages and stuff.
Okay.
And then the kids were like, are you teaching us like life lessons, or are you teaching us math? So again, this 4, -4, and this y, they can't be together. They have to be separated. So I'm going to divide everything by that -4. So these -4s go away. I'm left with that y equals, again, I have a negative here and a negative here. Both of those cancel each other out. They go away. And I can't simplify the 3 and the 4, so I'm going to leave them alone. So I'm going to have 3 over 4. And it's going to be positive because a negative divided by a negative is a positive. However, on this guy, I have a positive here and a negative here. Since it's opposites, a positive divided by a negative will give me a negative this time. And 4 goes into 8 2 times. Like when she tells us don't get married, guys. But then, yeah, exactly. See, my husband was nice and he brought me coffee, but he brought me coffee second period and it's all gone now. Granted, I don't need any more coffee. So then my equation right now is 3 over 4 x minus 2. And other than that 3, everything else looks like garbage. Yeah, well, it's not that you don't do anything when they're both negative. They just turn into a positive. So you actually did something. A negative divided by a negative turns into a positive. If you've never, like, if you're always having issues with multiplying and dividing, I always make this like Mickey Mouse. And it only works for multiplying and dividing. This is a horrible Mickey Mouse. But so it looks like a face. Wow, this looks so bad. Don't agree with me. Wow, that's rude.
It just doesn't look like Mickey Mouse.
It does not look like Mickey Mouse.
I guess we can say some kind of rat.
So yeah. So I'm finding this funny. Yeah, no, it just looks, yeah, it looks depressed. It's like some sort of anime stuff. So if I had something like this, then I can be like, okay, I have a negative and a negative. So I cover up his eyes. What do I have left? I just have his mouth. So it's going to be divide. But if I had a negative, not positive, like I have here, it doesn't matter which one's on top and which one's on bottom. I can cover that part and I have a negative right here. So then I know my answer is going to be negative. Obviously, if you have both positives, you can't do that with this guy because it should just be positive. You should know that. But with negatives, this is the little like Mickey Mouse guy that I made. Yes, he looks incredibly depressed, but you know, oh well. This is the cheap knockoff Mickey Mouse that doesn't get me, you know, copyright infringement and all that stuff.
Oh, true. That's true. She's thinking ahead of us.
Exactly.
We're
All right.
criticizing her Mickey, but she knows why she's doing that.
Exactly. Sure. All those things. All right. Do we feel a little bit better about question, you know, the bottom question? Thumbs up if yes, clap if no. And we're going to do more of these next week. So you'll see it again. So all of these bell works, you'll see it again next week. All right, I'm going to give up control and Ms. Gomez is going to need to take over. Ms. Gomez, you do have control, right?
Yes.
Okay. See, I did it all this week. Woohoo. Wait, all today. I mean.
Yeah, today. All right, so. Usually it's highlighted green, but I can't see. Do you guys see my class kick here, day 4? Okay, good. Just making sure. All right. So today is our day 4 of our solving systems of equations. But today you're going to learn a different method to solve your systems of equations. So some of you are not big fans of graphing. Some of you really like solving equations like what we just did now. So if you're a huge fan of solving equations, then you're probably going to like the substitution method. If you are getting a better understanding of graphing, then you can still continue to use graphing. But for today, we're going to be talking a new method, and that's solving systems of equations by graphing. So, sorry, not by graphing, by substitution. So substitution, you guys have heard of this word a couple of times already, but I like to always talk about sports because I used to be into sports. I know a lot of you told me that you're into soccer and you like to play soccer with your friends. So substitution, think about a sport, okay? In basketball, we have 5 players that are in the actual game playing against 5 other players. Well, when we have the 5 starting players, we call them starters. They're going to get tired if they keep playing the whole time. So to give them a little break, we use a substitute. We let someone come in and replace them, and they get their little break. So think about that. But now we're working with equations. So instead of replacing players, we're going to be replacing equations into one from another. So I'll show you what our objective is for today. So after today's lesson, you should be able to say, I can solve a system of equations by substitution. So remember, a system of equations is where we have 2 equations and we're trying to see where do these 2 equations intersect. So where do these 2 equations equal each other or have a solution? So how are we going to do that using substitution? Substitution is used to solve systems of equations by isolating a variable in one equation and plugging it into the other equation. So remember, isolating means we are wanting to leave a variable by itself. Once we know that variable, we're going to plug it into another equation. So let's go over to your class kick notes. And we're going to go ahead and drag that objective over. I can solve a system of equations by substitution. How are we going to do that? Well, we need to isolate a variable in one equation and plug it into another equation. So just 2 pieces that you're dragging over for now. All right, so we're actually going to see in how substitution works in a couple of examples. But if you remember, whoa, did you guys see that piece just move?
Okay, it's been doing that with like when I created it, like it was doing that. So I think it's it's ClassKick having crazy issues today,
There's a ClassKick ghost.
or it's that. I legit like that must be it.
Okay, so we're going to take a look at 3 different examples of how we can substitute, but these 3 different examples are going to show us the 3 different types of solutions. Remember, we have the one solution, that's where the 2 lines intersect at a point. We have no solutions, where we had the anime worlds, I mean your lines that don't come together, and your infinite many solutions, where we have one line basically on top of each other, or 2 lines on top of each other. So it's just one single line. So let's look at our first example. We want to solve the system of equations using substitution. What is it? Yes. We probably need that. Okay, so we have the first equation on this set here is y equals 3x minus 5. And the second equation is 4x minus 3y equals negative 35. Pay close attention to this first equation. When we see this, this is a good thing for us. We already have y all by itself here. So this is telling us that y is 3x minus 5. When you look at the second equation, we see a y here. So remember, if we have a player that's tired, we're going to replace him with a new player to help him get a little break. That's what we're doing here. We're literally taking one equation that we know y is 3x minus 5. We're going to take that 3x minus 5 and plug it in, actually replace it into that second y. So when we have y already here by itself, it helps us do that. We can replace it. So once you replace it, you want to rewrite this as 4x minus 3. See, we're keeping this 3. But our y here was replaced with the 3x minus 5, which is where this came from. And it'll equal negative 35. So we kept the 4x here, we kept the negative 3, and we just replaced the y, but we keep the equal sign and the negative 35. So give me a thumbs up if you see how I replaced the y's. Give me a clap if, I don't know what happened there. There's a lot of I don't know what's going on. Okay, don't worry. So in our first equation, we have y here is, think about this, y is 3x minus 5. They're already telling us what y is. When we look at the second equation, we see that this second equation has a y right here. So we can replace it with what we already know what y is. Or you can plug it in. We know y is 3x minus 5. So think of this y. We're going to swap these. We're going to put the 3x minus 5 in for y, which gives us this piece here. So we're just replacing it. And don't worry, we're going to get more examples of this, and maybe the next ones will be a little easier to understand. Okay, so after this, we want to take our equation, our new equation that we got, 4x minus 3 times 3x minus 5 equals negative 35. And we want to solve for x. We now have x in this equation, and we want to solve for x, just like we were working through those equations in your bell work. So we're going to take this negative 3 and multiply it by 3x. Since it's right next to our parentheses, we take negative 3 and multiply it by 3. Anybody that can tell me what is negative 3 times 3? -3 times 3?
-9?
-9.
There you go. Good. So this is a -9. And since it has the x here, we want to keep that x, -9x. Okay, anybody that can tell me what -3 is times -5? You have to multiply by everything in our parentheses.
15.
Yes, positive 15. Good job. So we get a new piece here. We simplified it a little. 4x minus 9x plus 15 equals -35. Okay, we're going to keep solving for x because that's our only variable now. So we have 4x taking away 9x. So 4 minus 9. What do we get? 4 take away 9. Yes, good. We get 5x. 4 minus 9 is 5. Okay, but it should be -5 because we have more negatives here. So it's like, let's think about, again, since Dr. Brown owes you guys a lot of money, she now owes you $9. She owes you $9, but she gives you 4. So she didn't pay you everything she owed you. She only paid you $4, which means she's still going to owe you $5. So that should be a -5x. So it's -5x plus 15. That equals -35. You can do your upside down T now. Since we have one single x here and just whole numbers on the left and right side. We can do the opposite. We're going to subtract by 15 on both sides. This 15 is just 0, so we get -5x equals -50. That -50 comes from the -35 minus 15. Again, we're going to come back, and after this page, maybe the examples will make a little more sense. Okay, so we're going to go ahead and take a look at what we have here. -5x equals -50. That -5 that's in front of the x, we need to divide both sides by that -5. See, this is just the solving equations that you were doing in question, the first question in your bell work. So -5 divided by -5, that's just x. And on the other side, -50 divided by -5, that's a +10. So after having two equations, we see what x is equal to. X is equal to 10. So we get one actual solid answer for x, and we now know what x is, so we can take that x and substitute again. So I'm going to look at our first equation, y equals 3x minus 5. Notice how this has an x here. I'm going to replace it. So if I replace it in here, I get y equals 3 times 10 minus 5. So all you have to do is the 3 times 10. What is 3 times 10? Anybody?
30.
Good job. So we get y equals 30. Take away 5, which gives us 25. So we get one solution. We got x was 10 and y was 25. So it's a point. These two lines do intersect, and they intersect at the point 10, 25. So we're going to go ahead and go over to your ClassKick notes. We're going to drag those pieces over. We started off with y equals 3x minus 5. And 4x minus 3y is equal to negative 35. We took that 3x minus 5 and plugged it in to this y. So our next piece should have that 3x minus 5 plugged in. That gave us x equals 10. So we plugged in that 10 to the second equation, and we got one solution. So this might be a little confusing right now, but don't worry. We will go through a couple more slides that actually show you with some movement how we plug it in. Okay, we're going to look at the next one. Let me go back. Were you talking about, yeah, okay. Since we skipped over a step here, we have y equals 30 minus 5, this step here. 30 minus 5 is 25. So we didn't divide by any 35s. Were you talking about this one, Jessica? This one here? Or before?
Yeah, it's like, do you basically just divide that 35? Like 30 and then minus 5?
Oh, okay. No, we just, all we had to, it could get a little confusing since this is right next to it here, but this was never here. Let's just pretend that was never there. That 25 came from taking 30 and subtracting 5.
So it came from the equation and you just use the x and you turn it into a 10.
Yeah, there we go. So we took that 10, put it into our x. Our x used to be here. So that gave us 3 times 10 minus 5, which is now 30 minus 5, which gave us y equals 25. So it could, by the way the presentation shows it, it could get us a little confused with that. Where did that 25 come from? But it came from 30 minus 5.
Okay, I was just making sure.
Okay. But that was a good question. Okay, let's take a look at the next one here. So just again, to show you how substitution works, at least for this whole page, what you want to see is how we replace it. So our two equations on the next example, we have y equals 5x plus 2. And the second one shows us y equals 5x minus 3. The first equation, we already have y all by itself. That's a good thing. When y is all by itself, it's telling us y is 5x plus 2. So we can take that 5x plus 2, and when you see a y in the second equation, you can replace it. So let's look at the second equation. Y is right here. Y is equal to 5x minus 3. We can take this 5x plus 2 and just replace it there. We're replacing this y. It's going to go away, and we're going to get this 5x plus 2 in its place. So we now have 5x plus 2 equals 5x minus 3. See, this piece took the place of y because y is that. Y is equal to 5x plus 2. So when you see this situation, when you see both of these, y equals, and let me show you. When you see y is equal to something here, and you see one right below it, the same y is equal to something here, you can just set them equal to each other because they're both telling us y is this, y is that. So we set them equal to each other. 5x plus 2 is equal to 5x minus 3. So now that we have this equation with just x in it, we can solve for x. So to solve for x, you have an x on the left side and x on the right side. We need to combine our variables, and we do that by using the opposite. So you can move one to the other side. So if I have a positive 5x, I'm going to want to subtract 5x on both sides. When we subtract 5x on both sides, they equal 0. 5x minus 5x and 5x minus 5x, they're both 0. Our x's went away. We have no more variables here now. This is one of those special cases where our variable goes away and we're just left with this 2, we bring it down, and this negative 3, we bring it down, we get 2 equals negative 3. So is this true? Is 2 the same as negative 3? Are they equal? Give me a thumbs up if that's true. Yes, they're equal. Give me a clap if no, they're not equal. Good. When we get something like this, 2 equals negative 3, that's not true. Since 2 cannot equal negative 3, we say there is no solution. So this is an example of no solution. Okay, let's go on over to our Classkick notes, drag those pieces over. We're looking at the middle section where we had both of them equal to each other and there was no solution. Yeah, that's a very good question. Yes. So let me go back. Very, very good point. Let me go back to this spot here where we had the 5x plus 2. We have the same variable here, 5x, the same coefficient variable here, 5x. We're saying the left side here, 5x plus 2, is the same as 5x minus 3. Well, technically, we do have the same variable with its coefficient. So 5x and 5x are equal to each other here. But when we see there's a plus 2 here, they're adding 2 on the left side, but they're subtracting 3 on the right side. We can already tell that there's no way that's going to be equal. So technically, yes, Jessica, if you're able to see that. Very, very good point. And actually, you're going to see this even more so in the next example. So we'll talk about that one next. All right. If we look at the next pair of systems, you have y equals 3x plus 1. And the next equation has 4y equals 12x plus 4. Again, the first equation is telling us y is 3x plus 1. Since we know what y is, we can take that which y is equal to and put it into our second equation for our y. So we're just taking this 3x plus 1 and replacing it where we see the y. So if I replace it, I still have the 4 in the front, but where y is, I should now have 3x plus 1. And that is equal to 12x plus 4. This right side, we didn't move. Okay, if you have a number in front of your parentheses, you just multiply. 4 times 3, 4 times 3 is 12, and 4 times 1 is just 4. So we get 12x plus 4 on the left side, and we're still keeping this 12x plus 4 on the right side. So at this point, you really don't have to do any more work. We can already just take a look at this and see we have 12x plus 4 on the left side, saying it's equal to 12x plus 4 on the right side. That is exactly the same thing. We have the same thing on the left side as the right side. When that happens, then we know we have infinite solutions. But if you want to see how it works out, you would still subtract the 12x on both sides to combine them. And we get 4 is equal to 4 when these go away. Again, I might be going a little fast, but we're actually going to get to see how these work out a little better in the next slides. Exactly. Good job. So see, if we subtract 12x on both sides, these x's go away again, but now you're left with 4 equals 4. Is that true? Give me a thumbs up if that's true. Is 4 the same thing as 4? Is 4 equal to 4? Good. Yeah, it is. So when this happens, when we get this type of solution, we say there are infinitely many solutions. All right. So I am going to come back here, take the last pieces over to the correct spot. And I'll zoom out. So for those of you that are following along only on Zoom and not being able to work on Kick Notebook, go ahead and take a screenshot of this now so you can complete the rest after class or when you have time.
Hey guys, let me add something. It has nothing to do with your assignment. Well, kind of to do with your assignment. I just sent back like 7 assignments to people because they're not showing me work. So the activity that we did yesterday, the maze, that has 2 pages. Both of them need to be completed. You need to graph in order for me to give you guys any points. And for the maze, there's only 2 boxes that you don't touch. Everything else you guys are doing. So out of the 14 or something, there's 12 of them that are done. So you need to be doing all of that. And for today's assignment, you have a homework assignment today. You see how we're showing you all the work? You need to do all the work. So make sure that you guys are showing me all of your steps, or else I'm going to kick it back to you guys. You've been warned. All right. Sorry.
Okay. So let's take a look at some examples. A couple more examples. So this will help you understand it, I think, a little better. Since we're not starting with really long pieces, we're starting with a little more simpler equations. So if you're really confused by that first page, that's okay. Now is the time to really focus in on these 2 equations and see how it works. It should help a lot more. So we're solving the system of equations, and they're both linear equations. We want to know, do these lines intersect? And if they do, at what point? We're still finding a point. So we have y equals 4x, and we have x plus y equals 10. Those are our 2 equations. If we want to find the solution, it helps if we take that first equation and write it on one side. So I'm just writing the first equation, y equals 4x here. I'm taking this second equation, x plus y equals 10, and I'm going to write it over here, x plus y equals 10. Okay, so we're doing that because we're going to be using substitution and then solving and then coming back and using substitution again. So that's it. You're just writing them on separate sides. Look at your first equation. It's telling us y is equal to 4x. Your second equation does have a y here. Since we know what y is, we're going to circle it, 4x, y is 4x. And we're going to go way right over here to this y and plug it in.
The we is very important, guys. If you don't do the we, it doesn't work.
Yeah, so We circle the 4x. Again, if you missed that, it's frozen. Why is it lagging? Okay, here we go. So we circle the 4x and we go wee right over to this other y right here. And you're going to replace it. So we have this x here. We didn't change it. This x is staying the same, but this y is going to be replaced by 4x. So there's where we get that 4x. And the rest we didn't change, so it equals 10. So give me a thumbs up if you see how we replaced it. Give me a clap if you're not quite sure. And it's totally fine. We're going to see this a couple more times. Okay. So now that you replaced it, look at your second equation. We don't have any more y's. We just have an x. And we can solve for that x here. So what is x plus 4x? You have 1x and you're taking 4 more x's and adding them together. What do we get?
5x.
Good job. Yes. X plus 4x is 5x. And that is equal to 10 because, again, we're not changing anything over here yet. So this is similar to your bowel work. If we have a 5 in front of the x, what do we have to do?
Divided by 5.
Divide by 5. Good. So we'll divide by 5 on both sides. When we divide by 5 on both sides here, we get x all by itself. And what do we get over here? What is 10 divided by 5?
2.
Good job. So x equals 2. We now found what x equals. And think about it. We started with 2 equations, but we got down to what one single variable is equal to. We got x equals 2. Now that we found x, that is going to help us go back and find y. So again, I am going to circle what x is. X is 2. X is 2, and I'm going to go back to my first equation over here. And I notice that there is an x here. So I can take this 2 and go, let me see when it comes up, and I'm going to go wee right back into that x. So we have y equals the 4 I'm going to keep, but I'm going to replace that x with what we got that x is. We're going to replace it with 2. See, so we have the 4 staying in front, but when we have the variable next to it, that's telling us to multiply. So what is 4 times 2?
8.
We get 8. Y equals 8. Yeah, you can do that if you want to. If you want to go that way. So now that you have a solution for x and you have a solution for y, we get a point. X is 2 and y is 8. So our solution is 2, 8, the point, 2, 8. So give me a thumbs up if this makes a little more sense after this example. We're still going to try another one, but what I want to make sure you're understanding, we're replacing, we're using substitution. We're taking what y is and replacing it in the other equation. So I got a couple more thumbs up, which is good. Yes, and it's one solution in this case. Very good. Since we have a point, it tells us, oh, these 2 lines do intersect and they have one solution. So in your ClassKick notebook, you want to go to slide 8. You already have that piece here. I think everybody should have that. Yeah, you guys do. So that piece is already there. But what we're going to do is work through another example. We're going to take a look at this second example and bring over the correct solution for that one. So we're going to try it one more time. All right. Let's go to the next one. It says x equals 3y is our first equation. So you should always have two equations when we're working with the system here. The first equation is x equals 3y. The second equation is 2x minus y equals 10. So in one equation, we already have a variable all by itself. If we're going to start by looking for the solution, again, we want to write our first equation on one side, just to keep them separate and help us see how we're moving one into the other. And the other equation, you can write it on the other side. So x equals 3y, I'll write it on the left side here. And 2x minus y, I'll keep it on the right side there. When you have these two equations, take a good look and see if there's one equation that already has the variable by itself. So can anybody tell me what equation has the variable by itself already? Is it the first one or is it the second one? Give me a thumbs up if the first one has the variable by itself, or give me a clap if the second one has the variable by itself. Okay, let's take a look at this again. See this first one here? Here's x. X is all by itself. X is isolated. This, if I were to read this, I would read it as x is 3y. If I read this over here, I have 2x minus y equals 10. None of these variables here are by themselves. They're right next to each other. So in this case, we switched it up a little, and it's now x that is by itself. Does that make sense? Give me a thumbs up if that makes sense. The x in the first equation is isolated. It's by itself. Yeah, okay. And that's going to happen since we worked with y's all the time. You're probably thinking, no, it has to be y. No. In this, we're looking for the variable that is all by itself. In this case, it's x. So we're trying to have you see the different cases. So here, x is equal to 3y. So since we know what x is, we're going to go ahead and circle what x is. We're going to circle 3y. Oh, well, you don't want to make those conclusions, basically the one in the front. No, that's not always the case. It's what variable is already isolated. When we say isolated, we mean what variable is already by itself on one side. Look at the second equation. These variables are right next to each other. They're not by themselves. They're not isolated.
And technically that second graph that she has, the 2x minus y, let's pretend that was a plus y. And then we could have just moved the 2x over to the other side, and then that would have been isolated. So if you don't like dealing with, y's as an answer because it freaks you guys out, you could always move the y's over and just have it as x equals. So it's not always the one that's in the front.
So you don't want to make those type of conclusions. What you do want to understand is, look at this equation. X is isolated. And that x is equal to 3y. So we're going to take that 3y and circle it. And we're going again, right over to the next one. You're bringing it in where that x is. This time we're replacing x with 3y. So we get 2. And instead of writing x, we're going to replace it with 3y. And everything else will bring down and stay the same, subtract by y, and equals 10. Okay, so see how we went from this equation to replacing x with the 3y because that's what x is, 3y. So we now have 2 times 3, which is 6y, minus y equals 10. So we just did 2 times 3. 2 times 3y is 6y. And we bring down that minus y and bring down that equals 10. So anybody that can tell me what is 6y minus y? Or 6 minus 1?
5y.
There you go. We get 5y equals 10. So now y is starting to stay all by itself on one side. Now we're solving for y here. How do we solve for y when there's a 5 in front? What do we have to do?
Divide by 5.
So we want to divide by 5 on both sides. Y here, 5 divided by 5, just gives us y. But what is 10 divided by 5?
2.
Good job. 2. So we get y equals 2. This time we solve for y and we actually know what y is equal to. So it's not always going to be y. It could even be x that we substitute for. So don't always think it's going to be one variable first. Okay, now we know what y is. Y is equal to 2. We're going to take this 2 again and go back to your first equation and substitute where we see that y. So take that 2, and you guys can make that sound with me. Wee, right into that y there.
Come on, I don't hear you guys. Hello?
Wee!
Wee!
Oh, that was fun. He's funny. Okay, so we take x equals, and that y, we're going to be replacing it with the 2, 3 times 2. See, we started off with the y here. We got this 2 from working through this equation here, and we're now plugging it in to this y, which gives us 3 times 2. So what is 3 times 2?
6.
So now we get x equals 6. And we have one solution again. We have the x coordinate is 6, the y coordinate is 2. So our solution is at 6, 2.
So it was the same as the first one, just that we were just solving for y.
Oh yeah. Was the first one? The first solution was 2, 8, wasn't it?
Yeah.
Yeah. See, our solution here is 2, 8. So technically, what you're saying is the first one had a y equal to 4x. So this time we did substitute. We did bring it over here to this y. This time we have what x is. So we're taking this 3y and bringing it over for x. So yeah.
But I mean that it's just a coincidence that they both had the same similar numbers.
Mm-hmm. Okay, so let's see. Let's see what you guys are thinking about substitution so far. It is a lot more steps, but some of you really like the algebra side of solving equations, and that's really all we're doing. We're solving equations, but what you have to do is substitute first. You take what we know and plug it in, replace it. And then you have to solve for one variable. When you solve for one variable, oh, okay. Oh, okay. Let me go back to that. So once you solve for that one variable, we have to go back and substitute again. So someone said, I don't get this part here. How did we get there? Okay, I'm gonna go back.
Also, guys, your exit ticket and your progress reports are both available. Before you leave, do both. Because the progress report is just like the exit ticket. It's just looking at it and making sure that, yes, I understand that these are my assignments. Please do that.
Okay, I didn't want any markings on there, so I had to restart it. That way you don't get confused. Okay, there was someone that said I'm confused in that middle part, which is okay. Oh, good. Okay, so how did we get there? Okay, good, good, good. Thank you for letting me know. That helps out a lot. Okay, so remember you had two equations. One you're writing on the left side, the other you're writing on the right side. It helps you to keep them separated. What should help you is this part over here. Look at the first equation. It's saying x is 3y. This equation has an x right here. So we're taking this 3y and bringing it over to the x, replacing it. That's how we got the 2 times the 3y. See, this x is not x anymore. We changed it to 3y because that's where we got this piece from. Does that help out a little more? That's where we got the 3y in there. So then the rest of that is you solving for y, which I see that you understand, but we just had to replace it. Oh, okay, I see that. So that happens because we're replacing. X is 3y. So the x is being replaced, and now when we replace it, we only have y's. Okay. All right. So then let me go back over here. We have 1 minute left, don't we?
Yeah. Some of the kids were like, class is like done, right? And I'm like, in like 2 seconds, hold on.
All right, so we're gonna go ahead and end here. So all you had to do was really drag that piece over where we got the solution 6-2. So the rest of these pages were extra credit, and you guys can work through these. Your turn, if you understood how to do it, then you can go ahead and try it to get 10 points of extra credit, and the last pages as well. But if you guys have any other questions, you can let Dr. Brown or me know.
And then there's office hours too at 12:10.
Mm-hmm.
However, for my normal group, I would like us to actually like work and not goof around as much. It's Friday. I really don't want to stay here like for 2 extra hours. So thank you. I'll be there. Okay, sounds good.
All
But
right.
12:10, guys, I will see you guys there. Have a very good weekend. See you guys later.